Regulations and standards, specifically NFPA 58, the Liquefied Petroleum Gas Code, requires static bonding and grounding when transferring propane between containers. UL 581, Standard for Static Electricity, specifies methods for static grounding and bonding in hazardous areas. A required procedure for static discharge connection is as follows. Prior to connecting the filler hose to the forklift tank, firstly ensure ground connection. Verify that the forklift is properly grounded to an earth ground rod or equivalent grounding system. Secondly, connect a bonding cable. Attach a static bonding cable, typically a metal clip with a wire, to both the forklift and the propane tank fill valve. For the grounding procedure, keep the bonding cable connected throughout the transfer process. Touch the metal portion of the filler hose, but not the nozzle, to the grounding wire before connecting the hose to the forklift tank. Hold the bonding cable firmly against the forklift and tank during the entire transfer. For the disconnect procedure, disconnect the filler hose before removing the bonding cable. Touch the metal portion of the hose to the grounding wire again before disconnecting the hose from the tank. Consequences of ignoring static discharge are that electrostatic discharge (ESD) can ignite the propane, causing an explosion. Injuries and property damage can result from ESD. Non-compliance with regulations can lead to fines and penalties. Additional information to consider is that the static bonding cable should be rated for the specific propane system and environment. Ensure that the bonding cable is clean and free of corrosion. Train all personnel involved in propane handling on the proper procedures for static discharge. Regularly inspect the static grounding system to ensure its proper function. Now, going into more detail about the standards themselves, NFPA 58, the Liquefied Petroleum Gas Code, is a comprehensive set of requirements for the safe handling, storage, and transportation of liquefied petroleum gas, including propane. It addresses various aspects of propane systems, from the design and installation of tanks and piping to the procedures for transferring propane between containers. This standard emphasizes the importance of static grounding and bonding to prevent the accumulation of static electricity, which can create a spark and ignite propane vapors. The code outlines specific requirements for grounding and bonding systems, including the types of materials to use, the size of conductors, and the methods for connecting grounding and bonding wires. It also addresses the need for regular inspection and maintenance of these systems to ensure their effectiveness. UL 581, the Standard for Static Electricity, provides detailed guidance on methods for static grounding and bonding in hazardous areas, including those where flammable gases like propane are present. This standard outlines the principles of static electricity and how it can be generated in various industrial processes. It then provides specific recommendations for controlling static electricity through grounding, bonding, and other techniques. UL 581 addresses the selection of appropriate grounding and bonding materials, the design of grounding and bonding systems, and the methods for testing and verifying the effectiveness of these systems. It also provides guidance on the use of static control devices, such as static dissipative mats and clothing, in areas where static electricity is a concern. It is crucial to understand that grounding and bonding are two distinct but complementary methods for controlling static electricity. Grounding involves connecting an object to the earth, providing a path for static electricity to dissipate safely. Bonding involves connecting two or more objects together, ensuring that they are at the same electrical potential, which prevents the buildup of static electricity between them. In the context of propane transfer, grounding the forklift and the propane tank provides a path for static electricity to flow to the earth, while bonding the forklift and the tank together ensures that they are at the same electrical potential. The specific procedures for static discharge connection are designed to ensure that grounding and bonding are effectively implemented during propane transfer. Ensuring a ground connection means verifying that the forklift is properly connected to an earth ground rod or an equivalent grounding system. This typically involves using a grounding cable with a clamp that is attached to a clean, unpainted metal surface on the forklift and connecting it to a grounding rod that is driven into the earth. The resistance of the grounding system should be checked regularly to ensure that it meets the requirements of NFPA 58 and UL 581. Connecting a bonding cable means attaching a static bonding cable to both the forklift and the propane tank fill valve. This cable is typically a flexible wire with metal clips on both ends. One clip is attached to a clean and painted metal surface on the forklift, and the other clip is attached to the propane tank fill valve. The bonding cable should be of sufficient size and material to carry any static electricity that may accumulate during the transfer process. The grounding procedure involves keeping the bonding cable connected throughout the transfer process and touching the metal portion of the filler hose to the grounding wire before connecting the hose to the forklift tank. This helps to dissipate any static electricity that may have accumulated on the hose before it is connected to the tank. The bonding cable should be held firmly against the forklift and tank during the entire transfer to ensure a good electrical connection. The disconnect procedure involves disconnecting the filler hose before removing the bonding cable and touching the metal portion of the hose to the grounding wire again before disconnecting the hose from the tank. This helps to dissipate any static electricity that may have accumulated on the hose during the transfer process before it is disconnected from the tank. Ignoring these procedures can have serious consequences. Electrostatic discharge can ignite propane, causing an explosion, which can result in injuries, property damage, and even fatalities. In addition to the immediate safety risks, non-compliance with regulations can lead to fines and penalties from regulatory agencies. It is essential to take these procedures seriously and to ensure that all personnel involved in propane handling are properly trained on the proper procedures for static discharge. In addition to the procedures outlined above, there are several other important considerations for ensuring safety during propane transfer. The static bonding cable should be rated for the specific propane system and environment. This means that the cable should be made of a material that is compatible with propane and that it should be able to withstand the environmental conditions in which it is used. The cable should also be of sufficient size to carry any static electricity that may accumulate during the transfer process. Ensure that the bonding cable is clean and free of corrosion. Corrosion can reduce the effectiveness of the bonding cable and increase the risk of static discharge. The cable should be inspected regularly for signs of corrosion and cleaned or replaced as needed. All personnel involved in propane handling should be trained on the proper procedures for static discharge. This training should include information on the hazards of static electricity, the procedures for grounding and bonding, and the proper use of static control devices. The training should be documented, and personnel should be required to demonstrate their understanding of the procedures before being allowed to handle propane. The static grounding system should be inspected regularly to ensure its proper function. This inspection should include checking the resistance of the grounding system, inspecting the grounding and bonding cables for damage or corrosion, and verifying that all connections are tight and secure. Any deficiencies should be corrected immediately. In summary, safely transferring propane requires strict adherence to regulations and standards like NFPA 58 and UL 581, which emphasize static bonding and grounding. The proper procedure includes ensuring a reliable ground connection for the forklift, connecting a bonding cable between the forklift and the propane tank fill valve, maintaining this connection throughout the transfer, and carefully disconnecting the hose and bonding cable in a specific order. Neglecting these steps can lead to electrostatic discharge, potentially causing explosions, injuries, property damage, and regulatory penalties. Additional safety measures include using appropriately rated and well-maintained bonding cables, comprehensive training for all personnel involved, and regular inspections of the static grounding system. By following these guidelines diligently, you can significantly reduce the risk of accidents and ensure a safe working environment when handling propane. The National Fire Protection Association, NFPA, is a global self-funded non-profit organization established in 1896. Devoted to eliminating death, injury, property, and economic loss due to fire, electrical, and related hazards. The NFPA delivers information and knowledge through more than 300 consensus codes and standards, research, training, education, outreach, and advocacy, and by partnering with others who share an interest in furthering the NFPA mission. NFPA 58 is one of their many standards. UL is a global safety science organization. They test, inspect, audit, certify, validate, verify, advise, and train and support these efforts with software solutions for safety and sustainability. UL stands for Underwriters Laboratories. The important element in this discussion is ensuring the safety of personnel and equipment when working with propane. Propane is a flammable gas, and static electricity can provide a source of ignition. Therefore, static control measures are essential to prevent fires and explosions. The described procedure aims to minimize the risk of static discharge by grounding the equipment and bonding the containers. Firstly, grounding involves creating a path for static electricity to flow safely to the ground. This is achieved by connecting the forklift to an earth ground rod or equivalent grounding system. The ground rod provides a low resistance path for the static charge to dissipate, preventing it from building up to a level that could cause the spark. Secondly, bonding involves connecting the forklift and the propane tank fill valve with the static bonding cable. This ensures that both objects are at the same electrical potential, preventing a potential difference from developing between them. If there were a potential difference, static electricity could discharge as a spark when the filler hose is brought near the tank, potentially igniting the propane. The procedure also includes specific steps for connecting and disconnecting the filler hose and bonding cable. Before connecting the hose, the metal portion of the hose is touched to the grounding wire. This helps to dissipate any static charge that may have accumulated on the hose itself. Similarly, before disconnecting the hose, the metal portion is touched to the grounding wire again to discharge any static that may have built up during the transfer process. It is crucial to maintain the bonding connection throughout the transfer process. This ensures that the forklift and tank remain at the same electrical potential, preventing the buildup of static electricity. The bonding cable should be held firmly against both objects to ensure a good electrical connection. The consequences of ignoring static discharge can be severe. An electrostatic discharge can ignite the propane, leading to a fire or explosion. This can result in serious injuries, property damage, and even fatalities. Non-compliance with regulations can also result in fines and penalties. Therefore, it is essential to follow the prescribed procedures carefully and to ensure that all personnel involved in propane handling are properly trained. In addition to the basic grounding and bonding procedures, there are several other factors to consider. The static bonding cable should be rated for the specific propane system and environment. This means that the cable should be made of a material that is compatible with propane and that it should be able to withstand the environmental conditions in which it is used. The cable should also be of sufficient size to carry any static charge that may accumulate. The bonding cable should be clean and free of corrosion. Corrosion can increase the resistance of the cable and reduce its effectiveness. The cable should be inspected regularly and cleaned or replaced if necessary. All personnel involved in propane handling should be properly trained on the hazards of static electricity and the procedures for grounding and bonding. Training should include hands-on practice with the equipment and procedures. The static grounding system should be inspected regularly to ensure that it is functioning properly. This includes checking the resistance of the ground connection and inspecting the grounding and bonding cables for damage or corrosion. In conclusion, static control is essential for safe propane handling. Grounding and bonding are effective methods for preventing the buildup of static electricity and reducing the risk of fire and explosion. It is crucial to follow the prescribed procedures carefully and to ensure that all personnel are properly trained and equipped. Regular inspections and maintenance of the grounding system are also essential. By taking these precautions, you can significantly reduce the risk of accidents and ensure a safe working environment.